So this first day in lab, you'll be given your kits for the semester and conducting an inventory of them. Then you'll build a motor testing rig out of Lego and build a 1-to-1 gear ratio with a pulley wheel. And then you'll conduct an experiment by loading the pulley wheel with various weights and recording the motor speed and efficiency as it lifts them. So first, kits and inventory. So first of all, you'll be each receiving one of these lists. Still some edits on the document needed, as you can see. First of all, section. If you are coming in at 8 o'clock, you are section A. If you're coming in at 11 o'clock, you are section B. You'll fill in your name and quid, and then we'll get started. Your toolbox should include the toolbox itself. And then you'll each have a screwdriver and a measuring tape. Then you'll have an Arduino board. There are a couple different models in your kits. It might look like this, or it might look like this. And it's associating programming cable. So if you have one like this, it needs the micro USB, which has an end like this. And if you have this model, your programming cable will look like this. All right, next is a motor driver board. Here again, there are two different models, and I'll explain the differences between them later. But first off is the Moto Shield. This is through SparkFun. Looks like that. And then next is the dual motor breakout board. Looks like that. You'll have one of those. And then next are contact sensors, also known as buttons. We just like to be fancy sometimes. You should have at least 2 of those. If you have more, just leave them be. You can have them in your kit, that's fine. Next are the brake beam sensors. We'll be going over those in lecture here in a few weeks, but for now you should know that they look like this. All right, so they either have wings here on the side or they may not, and they have 2 black plastic towers. And inside each of these, one side has an IR emitter and the other has a receiver. All of these components in your kit may or may not be wired already. That just depends on whose kit from last semester that you're receiving. Most of these are actually going to be brand new. We doubled all of our equipment this semester for individual projects. Next, you should have an IR sensor, which looks like this. It's got its itty bitty face. Again, 1 IR emitter and 1 receiver. Actually, I mix those up. This is the emitter, this is the receiver. You should have one of those. And then you should also have 2 Lego motors. Mine are kind of buried in the example bot that I'll show you guys later, but they are gray cylinders and they have connections for the Lego NXTs. And those should be blank in your kit. We'll also have a proto board, also known as a breadboard. It's something that you can use to make temporary circuit connections with jumper wires or pins. They each have 2 sides. One has a each side has a power rail. So if possible, you should always put positive power connections along the red line and negative or ground along the blue line. It just makes things easier. And then if you've never used one of these before, these lines here, the ones in the rows of 5, are all connected to each other. So it's the same as soldering 2 connections together if you plug them into the same row here. All right, next you should have 2 9-volt battery packs. These are rechargeable, and you should have 1 charger for them. That looks like this. It might also be a slightly smaller square. There's a couple different models. We can usually keep those on 2 amps. We're fine with fast charging. When you're charging your batteries, keep an eye on this light here. If it's green, that means your battery is fully charged and you should go ahead and unplug so as not to overload the batteries. You will also have a wall adapter, so you can plug your Arduino directly into a wall outlet. And it's going to have a barrel connector end, which that I can show you if I get this right. The wall adapter will have a cord like this, which can plug in your Arduino boards here and here. So that's your inventory kit. If you don't have this required quantity, leave that box blank. Come to me, I'll give you that component, and then go ahead and check it off. We're going to use the left column, which means you're checking it out for the semester. And then when we're done, we're going to use the check-in column later. So this form here means you accept responsibility for these components for the semester. If anything is, outrageously damaged or a large component lost, you may be financially responsible. We'll have to talk about that, but please try and avoid that as best you can. All right. So now that you finished your inventory, let's go ahead and talk about the two motor driver boards. So this one is the Arduino motor shield. It plugs directly on top of your Arduino, and all of the connections are already made. It's a little finicky. Be very careful as you're plugging these in. Cool. Once all the pins are seated, go ahead and press down gently. We're not going to push it all the way down hard. That's going to break some of the connections. Cool. So that's connected. And then the way this works is you will screw in your A motors here and here. There's 2 wire leads per motor. B here and here. And it's already connected to the battery power and the pins that control it. So here on the board, you can see it's written direction B, direction A, PWM B, PWM A. PWM means just the speed of the motor, and then direction is forward and reverse. These are the 4 pins that are automatically wired to control the logic of your 2 motors. These pins cannot change. As you can see here, they're written on. If you use this type of driver, those are the pins you got. You cannot use those pins for anything else in your code. So it's nice and simple, but if you have experience in soldering or wiring or would like to learn more about those, I would recommend this dual driver breakout board. It has the same, similar pins. These will come blank and you will need to solder them yourselves. So this is power and ground. Those will get screw terminals. Cool. And these are your motor A and motor B outputs. Those will also get screw terminals. And then these are your logic inputs from the board. Those will get header pins. And all of the terminals and headers are available at the soldering stations. Cool. All right, so that's how they will be placed, and you're going to solder them to the bottom. And then I have another example here, which is already done. So that one has all header pins, which is fine. That still connects just the same. And for this one, you're going to need a bit more wiring. So let me show you. Cool. So power is going to be this corner one, and ground is the one next to it. Power should be connected to V in on your board, which is right there. And that means it's getting the full voltage of whatever you plug in here, be it the battery or the wall outlet. Ground is just your standard ground here. Okay. And then IN 1 through 4, which is what these are labeled, these are your logics. Those go to any 4 PWM pins on your board. You can see the PWMs are marked with a little tilde that's squiggly right before the pin number. So you can choose any 4 there. I happen to do 5, 6, 9, 10. Just be sure to keep track of which one went in where so you can edit the code properly later. Cool. And then you're going to, these will be screw terminals for you, so you won't have to worry about that. But then you will screw in the motor A leads and the motor B leads, and then you are ready to go. All right, so after your motor controller is all set up, whether on the shield or on the breakout board, the next thing you want to do for lab 1 is make a circuit for a button. Now, this might be already soldered for you. If so, go ahead and plug the leads in. If not, here's how you would set one up. Or if you wanted to solder yourself, you can go ahead and do that. But you're going to be using a configuration called a pull-up button, which means that one side is connected to ground and one side is connected to a pin that's already set to high. It's already receiving power. And then when you push the button, it will connect that high pin to ground. It'll register as 0 or low, and that's going to signify that the button has been pushed. So this board is a little less messy right now, so I'm going to go ahead and show there, but there's really no difference. So what you're going to do is, if you want to use the breadboard, you're going to plug it in with 2 prongs on the same side there, and you're going to put in a jumper wire to one side. That's going to be ground. And then the other side goes, I'm going to use pin 2 because that's what I wrote the example code for, but you can change that if you want. And then the code is going to set this pin to high. And then if you press the button, it's going to connect to this circuit and it's going to register as low. And that will make the Arduino know that the button has been pushed. So that's all the circuitry you'll need. If your button's already wired, you'll have 2 leads coming from these 2 prongs, and you're going to plug them into 2 and ground just like we did here. So that's all of the circuitry and wiring that we need. Next, you're going to go to Canvas and download the example code if you haven't already. So this is the example code that's been provided to you on Canvas. So everything should be ready to go for this lab. If you had used a different push button pin, you would change that here. If you use different PWM pins than I did for the breakout board, you would change that here. Otherwise, this is all set to go. Feel free to make edits if you would like. If you wanted to change it around somehow. What this code is currently set to do is when the button is pushed, and as long as it's pushed, it's going to run the motor at full speed. It's also going to take time measurements. So it's going to count the amount of time that you have the button pushed down, and it's going to display that on what's called the serial monitor, which is up here. I don't currently have a board plugged in, so that's what it's angry about. Let's go ahead and do that. When you plug in a board, if your computer has sound enabled, you should hear when it's connected. Mine didn't make a sound because it's on mute right now. But now we can see that the board is plugged in. And as soon as a board's plugged in, you want to make sure that you have the right COM port. So that's under Tools, Port, and you should select the one that says Arduino Uno. Make sure that this board says Uno as well. That's necessary for your board to be able to download stuff. So here I'm going to open my serial monitor. This is just a text box that shows feedback. Right now, the program that's downloaded is a distance sensor, which we don't need right now. So I'm going to go ahead and compile the code, which is making sure that there's no errors. And that takes a second here. So as soon as you've downloaded this code, go ahead and explore it. The comments should be enough explanation for you to figure out what's going on. If there's any confusion, please let me know and I'll walk you through it. But definitely be sure that you understand this code fully before you start downloading and experimenting. This second tab here, I've pulled the functions that control the motors out into a different area just for cleanliness. You shouldn't have to touch this file at all. It'll be written and ready to go for all of the labs this term. Cool, done compiling, and there's nothing red or orange in here, which means that there was no errors. So I'm going to go ahead and download the code to my Arduino. Cool, it's done. Well, uploading, upload, download. It depends which frame of reference you're in. So it's done with that. So if I go ahead and open up the serial monitor, and if I have my button connected to pin 2, then it's going to, so when it records the time, it's going to do so in milliseconds, because that's what computers use. All right, I've got my button plugged in. So now I'm going to press down on the button, and you can see that's the time according to the computer when I pressed it down. And when I release, it finds what time that was, and it takes the difference. I was holding down the button for 5.3 seconds. And that's how you'll measure the time it takes for the motor to lift up a cup of specific washers. Now, if I plug in my motors, to this circuit. Now it should activate the motor at the same time when I press down the button. So not only will it record the time, also going to run the motor. Cool. All right, so I can only have one thing on screen at a time, either the Arduino or the robot. So hopefully audio cue is enough. Here I'm going to press down the button. And I don't have external power plugged in. So that's an important point. When you're running the motors, you should always have a battery. Or in this case, for this lab, we're always going to use the wall outlet. You should have one of those plugged in before you run any motors. So lesson learned. I've now got my power plugged in. And now when I press the button, the motor will run. All right, and we're back. Somehow it turned out my wiring was incorrect. I'm not sure how, but I started over from scratch and that fixed the problem. So that's just a little lesson learned in wiring. There's going to be lots of errors as we go on. Everyone does it. You just have to be able to think logically about how the error might be fixed. So here we go. Push a button, start time, and motor. I don't know if you can hear it, but that is the motor going. And release, the motor stops, 4.4 seconds. And then you'll use that data to fill out your spreadsheet as you add various weights. Now that that is all working, be sure to test this code and your motors before you start building anything. If you wait too long, then your thing is all built, but it doesn't work, and that causes problems. So testing hardware first, and now we're going to go build our rig. All right, some tips on building with Lego for our class. So we have a lot of Lego here in the lab. First of all, we have the standard Lego type pieces, nice big solid bricks. We also have standard Lego connectors, but with holes in the side. These will be very useful for your axes. And then we also have a bunch of pieces from a type of Lego kit called NXT. And these are various shades of gray. They come in all sizes, shapes, lots of different connector pins. So here is the black or gray ones. Those ones will allow for rotation if they're only plugged onto one other piece. There we go. If you want a solid connection, you'll use the small blue ones with the cross at the end. And then it only rotates on one side. This one is stuck in place. And then there's lots of different connectors for those. And then this is also where you'll use your axles and spacers. So this is a spacer. The yellow ones are about half the size of the gray ones. And they're buried in the bin. Either way. So I would highly recommend building your bot when we get around to it with the NXT gray pieces. These can also come in handy for right angle connections, but these will make your bot very dense and very big. So try to avoid those as much as possible. So here are some of our various pieces, and they can be used to put together your motor rig. This is my example. I'm not going to let you look at it too long because this is part of your creative assignment, mechanical design. But some of the most important things you want to include is that your motor should be securely connected to your rig. Might also put a support over here if you wanted. Each motor shaft should be supported on both sides, so it's not just dangling out into space. Okay, and then your gears should be the same size, which gives you a 1-to-1 gear ratio. So this is your drive shaft. This is your output shaft. Your output shaft should be longer, so that we can put on our test pulley. So some of these are already connected, some of them are not, but you should have a small white round piece. This is actually the hub of a tire that we took apart. And then we're going to tie some fishing line to it. And at the end is a cup. And you should be able to put this on your output shaft. Spacers are also useful for making secure connections. And then this should be long enough that it can hang off the edge of your desk, which is at a frame, so I won't show you that right now. But yeah, so everything should be well connected so that when you turn it on, so in your case, you'll have your wall outlet, but for now, I just have my battery. I'm not going to do any actual experiments with this. So, battery, motor will be these guys. And then my Arduino is not connected to the serial monitor right now, but if you plug in your programming cable, you can open that serial monitor window and take a look at the motor timings. Sorry, a little cutaway there. My motor wasn't a good one. So now we're all set to go. You would have this pulley off the edge of your desk, and make sure that it's all supported. You can use your hand, you can use some extra weights. And then as you can see here, that wasn't actually winding because it wasn't in line, but if I do this, there we go. And that's your motor rig. The rest is up to you for your experiment. Thanks, everybody.